Okay, before we take a look at this problem here, let's go to Desmos and see what's actually happening. This red curve is the graph of y equals 1 minus x squared. We've got this rectangle with its base along the x-axis and the upper two corners or vertices lying on that red curve. So if I go to Desmos, there's a picture where this curve came from. But see, if I change this value of a, those are some of the different rectangles that you can get. And this is the area based on the value of a, which I'm letting a be the distance from the origin out to this lower right-hand vertex. And then if I take f of that number, I'll get the height. So there's all these different rectangles. And one of them has the greatest area. And we want to find the value of a that will give us the maximum area. So let's go back to Wyzant and take a look. So we need a formula for the area of this rectangle. So I chose to let this distance right here be x. And that means that this height right here is 1 minus x squared, that x value squared. Of course, if I use coordinates, this will really be, this is negative x comma 0. But the idea is that the length of the base of this rectangle is 2x, and the area of the rectangle is length times width, or base times height. Okay, so I wrote this as 2x minus 2x cubed. And I'm restricting x to be between 0 and 1. It wouldn't matter if I went this way, but let's just say that x is that distance. So the derivative of a of x is 2 minus 6x squared. While I'm at it, I made note that a double prime is negative 12x. But if I set a prime equal to 0, that'll give me my critical numbers. So 6x squared equals 2, x squared equals 1/3, x equals plus or minus the square root of 1/3. I'm choosing to let x be this little positive distance here, so radical 3 over 3. Now, if I plug this number into the second derivative, I see that I get a negative number. So by the second derivative test, this number is giving me a maximum, a relative maximum for the area. Okay, and if I go back to Desmos, there is, I let k equal radical 3 over 3, so that's the value that gives me the maximum area. I set this to k, and if I want, I can enable this point right here. Oh, not that point. Oh, here's what I was going to show you. There's the derivative function right there. I'm sorry, the area function. And that value, that area function reaches its maximum value at radical 3 over 3. Okay, so there's the width, that's k. You need to double that to get this dimension right here, and plug that number, radical 3 over 3, into 1 minus x squared to get the height. Okay, there you go. Hope that helped. And if you have any questions, post a comment.